Hi, students. Let's look at this question, which is on the rate of change of connected rate of changes. So a vessel is in the shape of a right circular cone. The radius of its top is 8 cm and the height of it is 40 cm. Water is poured into the vessel at rate of 20 cm cubed per second. Calculate the rate at which the water level is rising when the water level is 12 cm from the vertex. So I think the vessel, okay, this right circular cone, they did not state that whether it is upright, as in is placed, how is it being placed, upright or top down also. So I think what they're trying to say is this cone look like something like that. Okay, then after which the radius of the top is 8 cm. Okay, and the height here is 40 cm. Okay, so water is being poured into this vessel here at dVdt is 20 cubic centimeter per second. Calculate the rate at which the water is rising when the water level is 12 cm from this vertex. Vertex is this pointy edge here. So meaning if say I've got water level here, what would the this is the water when this is the height. It is varying, okay. So that's what I think. So this case here, what we need is actually the volume of water here. So let's say this is small r and this is big R. So we need to find dH dt, the rate at which the water level is rising, which is dH dt. Okay. This is when H is 12. Okay, then the next one is when V volume is equals to 1/4 of the full volume. Okay. So that's the difference. So we do the first, I think we do the first one. Once we do the first one, the second one should be quite okay. So the volume of water is actually let's say this volume of water, which is 1/3 pi r square h. Okay, but problem now is that you have two variables here, r and h, right? So what we need to do is make sure that we, by similar triangle, okay, we need to relate them. So 8/40, which is this entire thing, will be similar to this triangle here. Okay, so that's what we need to do. We have to find a way to connect them. So we're gonna use the property of similar triangle here to just relate to these two variables. So this guy, what we'll get is 8/r is equals to 40/h. Okay, so we know that this is 5. 40 divided by 8 is 5. So this is h equals to 5r. Okay, so this guy will be h, or rather r is equals to h/5. Okay, I make it in terms of h because this is in terms of h. So v is equals to 1/3 pi h/5 square h. So that will be 25 times 3. That will give us 75. Okay, there you go. So what we need now is actually dH dt. So dH dt is actually dH something dt. Okay, so we know that dV dH will be 3/75. That will be 1/25 pi h square. Okay, so this obviously is dV, this is dV. All right, so this is pi h square over 25. So if you want dH dV, I'll just take the reciprocal of it, which is 25 over pi h square. Then dV dt is the volume going in, is 20. Okay, so that will be so dH dt when water level is 12, 25 times 20 pi 12 square. That will give us 125/72 pi cm per second. Okay, that will be the answer for the first one, A. Then the next one will be the height when the vessel is 1/4 full. So when vessel is one quarter full, we need to find out what is the height of the water, because we have got DHGT in terms of height here. Right? So DHGT, if we simplify it, DHGT is in terms of 25 times 20, that will be 250, 20, no, 500 over pi h square. So we need the vessel to be one quarter full. So essentially, when V full will be 1/3 base area, which is 1/3 pi 8 square times 40. Okay, one quarter full. So I mean the full when it's full. So when it's one quarter full, will be one quarter of this entire thing, right? So can calculate. Do we need we don't need in terms of pi, so 3SF. So 8 square times. Okay, this is one quarter full. This will be 340 third pi cm cube. Okay. Now what we need now is to find out what is the height when it's one quarter full. So we know that this will just be 1/3 pi r square h, right? But pi r square h, like we established that pi r square h is actually the volume, which is this one. So I'm gonna use this guy 1/75 because I don't want to find the radius. So this one quarter full, we just use this to find out what is the height of the water. Okay, that's it. Then once this is done, we could just find out. So let's cancel this out. So that will be h cube will be 16,000. So cubic root h will just be 25.198 cm. There you go. So once this is done, we know DHGT h is equals to 24.198 will give us this guy here, 500. Okay, key in calculator. So this will be 0.2506, so 0.251 cm per second. Okay, 3SF. That's 3SF, right? Yep. So that's how you do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.